All right, the session has begun. So now I'm going to go ahead and just, as I always start every class, I'm going to start with doing the looking over at the syllabus. Well, not syllabus, but the scheduled activities. All right, so we've covered now lesson 1, 2, 1, 4. So that was last week, right? And then you guys completed, at least you should have completed all these assignments, although they're not due until this time. It should have been completed by now. But now we're going to look at 1.5 and 1.6 this week. All right, so 1.5, let's take a look at that. All right, now let me start this. All right, here is the book. It's called The Coordinated, actually, but The Coordinated Effort, but it's the coordinate effect, really. The coordinated effort. But now, when we look at coordinate planes, all right, we need to really recognize the rectangular coordinate system, as well as how to connect data to represent a series of, I guess, ideas. I mean, I don't want to say it's like, oh, here's a problem, or it's, I want to be careful because, when we look at a series of data, it normally gives us trends. The idea is just an overview of what's the commonality of this interaction between different events that can impact each other. Such as, like, here's an example. The amount of income we have, right, dictates what I don't know, I would say resources. That's a good word. So we really think about what the impact of one thing has on another. Right now, it's a little chilly all over the place, right? So most likely people aren't going outside, kind of things like that. Here we have time series of data, and we're looking at, okay, here's the years, and this says most people with the that the economy of the United States went through a very rough patch starting late 2007. So we look at the trends of the data, and we see that what happens in the percentage rate, and we can look at the common measure of the strength of the economy is through unemployment, right? So the percentage of unemployment rate, you can see if you look at the unemployment, it's like right now at 2003 it's 6%, and then we can see right here that it's spiked up significantly right here. Look at that, it went up to 9.3%, 9.6, 8.9, 8.1. Those are significant regions of, those are a lot higher percentages than the other set of data, because of course if you were aware of this, but there was a big crash in the real estate market, and it really put a damper on the economy. So anyway, this is capturing that. It's just showing you what the percentages look like as far as unemployment. It wouldn't have been a bad time to be getting look at this. You have only 4% of the population in 2000 was unemployed. That's pretty darn good. If you look at the rest of the data, there's nothing even close to being that. I mean, the only thing you have is 4.2. That's pretty close, but the rest of it is around 5 or 6. So anyway, that's interesting stuff. But now, when it comes to it, the data starts doing this, right? I mean, you could start plotting that, and when you're talking about plotting it, it creates a visual effect of what trends are doing. So that way, that's a little annoying to have to look at all that data right there. I mean, that's a little annoying to look at that. So what you could do is you can plot it on a coordinate system, all right, and see what the trends are doing visually rather than knowing what the exact numbers are. So you can see that it was pretty high, and then it steadily was going down all the way up until 2000. Then it spiked up again, and then came back down. But then once that real estate market crash came about, created a lot of unemployment. It spiked the unemployment rate to a record high and during this time period, and then it came back down. So interestingly, we can see how the trend works, all right? And that's through graphing coordinate points. Now, you can go ahead and see here, they're making markers at 4.9, all right? And they're just making different ways of creating, all right, markers. And it's a matter of taking and understanding the coordinate system plane. And when we're looking at vertical and horizontal lines. So the rectangular coordinate system is made up of an x and a y axis. And we can see that on the bottom of page 16. All right. So you can get a lot of good information. And scales make a difference. The scale is how it's been incremented. Look at that. It went from 0 to 2, 2 to 4, 4 to 6, and so on and so forth. All right. And that's the percentage of unemployment. And then, of course, this started in 1992, but if you look at the next one, it's 2000 or 1995, and then 2000, and then it increments by fives, right? So that way they can collect the data. So that's a scale. The scale, in this sense, then would be in increments of 5. All right, outside of the 1992. All right, so then you have the origin. The origin is when the two axes meet. And you should know this by pre-algebra, all right, that this is what the coordinate plane looks like, where you have the horizontal line is the x-axis. The vertical one is the y-axis. All right, very important that you know the difference between the two, which one goes vertical and which one goes horizontal. Because every coordinate point, all right, every coordinate point we look at is made up of an x and a y. See, so if we look at it, every coordinate point is made up like this. And therefore, we always say that the first coordinate point of a point is telling you where to move horizontally. If it's negative, it moves to the left. If it's positive, it moves up. If it's the y value, or the second number within the coordinate point, that tells you where to move vertically. If it's going up, it's positive. If it's going down, it's negative. All right, or vice versa. All right, and when I say vice versa, I mean if it's the value is negative, that's telling you to go down. All right, if it's positive, it means it's going up. So the point of this origin is right here. Okay, that's 0, 0. All right, that's when the two axes meet. So you can plot these different points. All right, and the different points, as you can see, are plotted already for you here. All right. So just to let you know. But if you need more ideas about how to do this, I'll be teaching you how to do it when I go ahead and do the ALEX. But you can really see a lot of data, all right, generated from this coordinate system plane stuff. So important features of good graphs. They give you good information here on good features of graph. But here we have that every coordinate point, there's years are dedicated to the years are dedicated to x-axis. Because time is something that can't be controlled. So the input shouldn't be controlled. It should be the dictator. So years are our input. Now the output, the price per gallon of gas, is dictated by the year after 2006. So we have 2006 and then the year after. So that's the starting point. So we say the starting point, since it's 2006 is the starting point, we say 0 to 32. And then it's tracking it for a span of 10 years, right? And then you're seeing the different fluctuations of gas prices, all right? And so you can then get a visual. Now, all this has not been given to you. What's in blue is obviously the instructor's annotated answer guide. So this has not been provided to you. You would have to create this yourself, all right? So you can see the trends of the data by being very meticulous about how you graph these coordinate points. Now, some of you might be like a little bit off, and that's okay. But as long as you're not extremely off, like, if it goes right here, we know that it's 232, right? 227 should just be slightly less than 232. Not, oh, here we have it at this point, and then underneath 2. That wouldn't make sense. So it should be slightly less, and it is. You can see it's 232 here, and this is kind of going down a little bit. So it's a little bit lower, and it doesn't have to be perfect. The data has already been indicated here. It's not like we need it to be perfect. We just need to show a little bit of a difference, and then we go back up to where it shows 305. So you put a little bit above $3, and so on and so forth. You get the idea now. But I see some radical things going on with students. I'm like, what are you thinking when you're doing this? I mean, what is the purpose of anything? Is to depict that data properly here. I mean, it's not that complicated. It's already been provided to you, this graph, so you don't have to recreate this. It's just a matter of applying some points. But people make it harder than it is, and then they start complaining about it. So there's a lot of questions here talking about it, like when was gas most expensive, and then they again make you want to go ahead and look at the graph that you created, or you can also just go back to the coordinate points that you did, all right? And they warn you about like things like, again, you may have two slightly different answers, and that's okay, all right? That's okay to have it a little bit different. But when did gas prices start relatively level from one year to the next? And then they go ahead and talk about this. One meaning level is something like this or something like that. All right. When is it level? Meaning it didn't have a sharp increase or decrease. All right. So anyway, I wanted to point those things out because the coordinate effect, the coordinated effect or effort is a matter of just recognizing trends in data. So let's take a look at your lesson from Alex now, just as a way of introducing this in that realm, and see how that it can impact you on your lesson. All right, let me get started here. All right, now, this is what I was saying. If you don't understand how to graph coordinate points, I'll do it right now with you. So I was indicating to you that we have this is the x value where we are x. So see, this says x right here. This says y right there. All right. So we're going to move 1 unit to the right because it's positive up here. So it's positive. Now the next number tells us where to go vertically. So then we're going to go down because it says -4. And that's it. We're done. All right. There's nothing really big surprise about this. All right, we're going to do that one more time. We're going to go down -4 and then -3. All right, since it's so easy, I don't mind doing more. So that's -5 or -6, excuse me, then pi, and then 5, -1. See, it's nice and convenient. It's pretty easy. Now we're identifying the ordered pair of Phoenix. So we go to Phoenix and we see it's -8 for the value of x. So we're going to put -8 for that one. Move it over to y, and then identify that it's -10. All right, this moves pretty quick. So burn. So we're going to go ahead and do 1, and then -5. Denver, -5, 3. All right, maybe I get, oh, it's -7, excuse me. See, not that big of a deal. All right. London, -16. Now, a lot of students love this. I mean, it's like, this is on a test or final even, I saw it. So it's not on every final, so don't get too excited. But A to B is constant. B to C, right, is increasing. C to D is constant. And D to E is decreasing. And so I'll just go through this. This is increasing, constant, decreasing, increasing. You can see there's quite a few of these, so that way you make sure that you understand how it works. But most students are very, very solid in this. All right. What was the greatest number excuse me, what is the greatest number of orders in a month? So this is the number of orders. So we're looking for the highest point. So, and that's the highest point is right here. So that point resides between 2100 and 2200. So that must mean 2150, right? When did the number of orders have the greatest increase? So the greatest increase was from July to August. That was the greatest increase. Again, if there's anything I'm doing that's going too fast or something, let me know. What is the greatest donation amount in a month? So this is the greatest donation value. So that's going to be 4,800. And then when did the greatest decrease in donation occur? That's from October to November. All right, what was the least value or number of visitors in a day? The least would be right here on Thursday, and that would be 305. Whoops, all the questions. When did the number of visitors have the greatest increase? Well, that's from Friday to Saturday. And this will be the last one. What was the least donation amount in a month? Well, that would be in December, and that would be $2,800. And And then when did the greatest decrease in donations occur? The greatest decrease is from October, November. And that's it. That was all that lesson was about, was coordinates and then being able to understand and interpret information from coordinates. All right, are there any questions? Pretty easy lesson, right? Now it's a matter of doing your work and getting it done, right? All right, so go ahead and if you have any questions, let me know. Otherwise, have yourself a great day.